Okay, so we are going to do linear motion and free fall unit. This is the introduction. We're going to go over a lot of vocabulary and kind of cover some of the formulas that we're going to use in this unit. So there's a lot of vocabulary and it's all pretty important for this one. So let's jump right in. Alright, so a few pages in. This is the first page with lots and lots of vocabulary, and let's discuss. So first thing we're going to talk about is distance versus displacement. So the definitions for distance is how far it travels. That's pretty basic, pretty obvious. So if you leave your house and go to the store 4 miles, and then you come back 4 miles, the total distance you travel is 8 miles, right? Or 8 kilometers, we'll say. Displacement is how far something travels in a given direction. So this is a little bit different. So in order to understand that, let's draw something out. Let's say our house is here, and every line I make is going to be 1 kilometer. So if I go 1, 2, 3, 4, 5, my total distance is 1, 2, 3, 4, 5 kilometers. 1, 1, 1, 1, 1. Now, my total displacement, like how far I am from my original point, is really just 1 kilometer, right? Because I'm only 1 kilometer away if I end here. So distance is how far you travel total. Displacement is how far you traveled in a given direction. So I've only went 1 kilometer this way. So in this case, distance is 1, 2, 3, 4, 5 kilometers. Displacement is 1 kilometer. Let's do another one just so we get it, right? So let's say this is my house. Again, every line is 1 kilometer. 1, 2, 3, 4. So if you can guess this, your distance is 1, 2, 3, 4 kilometers. Whereas your displacement is actually 0, because you're nowhere further away from your house than you were. Because you technically haven't really traveled anywhere in a given direction because you ended up back at the same place. So that's distance versus displacement. Okay, so let's talk about a few more things. Let's talk about speed versus velocity. Okay, so this one's pretty easy. It gets, I guess, somewhat confusing. I don't think so when you get to the formula, but still not. So speed, an example of a speed would be, let's say, 20 miles per hour. I'm going to start using kilometers from now on, so just convert that in your head as you will. So let's say 20 kilometers per hour. This is our speed. Our velocity, we could say 20 kilometers per hour north. So if we look up here, if we look a little bit lower, speed, how fast something is moving. So as our example said, 20 miles an hour. Velocity, how fast something is moving in a given direction. So 20 miles an hour north. So this is really what makes a velocity. Okay, so let's look at these formulas. We're going to jump around a tiny bit, but that's okay. So the formula for average speed is distance traveled divided by elapsed time. So our average speed, so we're going to say average speed equals distance traveled, how far you went, divided by your time. So this is the change in time. Okay? So that's your average speed. The formula for average velocity is your displacement divided by your time. So that's the difference. We just talked about displacement. Oops, excuse me, this should be T. Divided by time, right? So to rate that in a better way would be your final distance minus your initial distance divided by your final time minus your initial time. So this little O here, that just means your starting time, right? Now let's come back up just a little bit and let's go over these two. Okay, so let's talk about distance versus displacement. Just to kind of cover this, I'm sure you guys will read it anyways. Distance is an example of what we call a scalar quantity. Okay, so distance is scalar. In other words, it has a magnitude but no direction. So scalar, like a scale, has a magnitude but no direction. Displacement is an example of a vector quantity, because it has both magnitude and direction. So scalar means just magnitude, distance is scalar, vector has magnitude and direction. Okay, so just make note of this. Average speed is distance traveled divided by time. Average velocity is displacement divided by time. And this right here is sort of your final formula, what it looks like if you break this up a little bit, okay? So, with that being said, we'll go over a few examples in the next video, and let's rock and roll. You guys are going to do great.